So for that process to happen, for the applicant to get a certificate, which again is nothing else but the applicant's public key and the applicant's identity information signed with the CA's private key. So of course, for this to be a standard, so that we can properly understand each other, like we can validate the certificates back and forth properly, we need some standards. And while there are many standards involved in the PKI process, two are most important. One of them is the one which defines the format of the certificate signing request. Like when you want to go to your government to get a passport, you fill in a specific formula in there, which is standard, which you fill in your data in there. So we need a standard to how to define the format of the certificate signing request. So that's going to be the applicant's request that states, "Dear CA, I want a certificate." And also we have another standard X509, which defines the structure and format of the certificates. So once we need a standard format for the request. So the all CAs need to receive the request in pretty much the same format. They're going to validate the request as we looked before, and then when the CA issues the certificate, is gonna put that in a specific format, which is standard, which is X509. So those are the two most important standards. Otherwise, and nowadays X509 uses version 3 to define digital certificate formats. Now in the certificate there's going to be a lot of fields in there, a lot of data attached to the certificate, but the mandatory fields of a digital certificate is per version 3. It has to be the version and the serial number. So version is going to be version 3 clearly, and serial number is that because the CA issues multiple certificates, it has to make a distinction between each passport it issued or the CA between each certificate it issued. So what happens is that the CA is gonna assign a serial number to each certificate that it issues to applicants, which is the same thing like each passport has a unique serial number identification in there. Then the certificate has a subject name, which the subject name is nothing else but to compare that with the passport issuing process, is nothing else but the supplicants or the requester's identity information. Like what is your name, what is your birth date and last name, first name, birth date, and so on, which from the certificate point of view, that's going to be called as the subject name. It also contains the subject public key and public key algorithm, because we know that when the applicant sends the CSR request to the CA, that's going to be nothing else but its identity, which is the subject name, and its public key, because that's the scope of a certificate. And the public key algorithm, because of course the private public key pair can be generated following multiple algorithms. Like it can be an RSA key pair, it can be a DSA key pair, it can be a Diffie-Hellman key pair, so it depends. And of course, it's going to contain the validity period. Like when the CA issues, this is information which is attached to a certificate by the CA. It's like the same thing with a passport. When they issue you a passport or visa, it's not lifetime valid. It's valid for a couple of years, and the same thing with a certificate. So when the CA issues a certificate, it's going to put in there the validity period of the certificate. You're going to put in there, of course, in the certificate the issuer name, which is the CA's identity. Like for example, when you look at your passport, it says somewhere in there, issued by the government of your country, whatever your country is. The same thing in here. We have to put on in the certificate who issued, which authority issued that certificate. We're going to see in a couple why that's important. And of course, the CA signature algorithm and CA signature itself. Because as we saw before, is that when the CA issues the certificate to the applicant, is going to take basically the applicant's CSR information, which is the applicant's public key and the applicant's identity, and sign that together as a document, sign that with its own private key. So it's going to see in a couple. It's going to speak more in a couple about the signature process, but because it's going to sign that document, it means that the CA has to attach to the document the signature and the algorithm used to come up with the signature. And of course, there are other standards. PKI standards, a lot of them. You can read on Wikipedia on that link. Now, the enrollment process, as we saw before on the Wikipedia diagram, is of course that the CA has to first generate a self-signed certificate, which means the CA generates a private public key pair. Then the identity information is configured, like the subject name of the CA. Then also the validity information is configured for both the self-signed certificate and certificate issued to applicants. So when you actually create a CA, you have to tell the CA, okay, what is the identity of the CA? Because the identity is going to be attached to the certificates issued to applicants. And what is the validity of the certificates? Because the CA needs to know what is the lifetime of its own self-signed certificate, and also what is the lifetime of certificates that is going to issue to applicants. And of course, the signature algorithm for issuing certificates is configured. You can pick and choose between different algorithms. And then what happens, the last step is that the CSR of the CA, which is CA's public key and CA's identity information, is going to be self-signed with the CA's private key, and that's the CA certificate. And at this point, the CA is up and running and ready to issue certificates to applicants. Now, when the applicant enrolls with the CA, which means the applicant wants a certificate or a passport, of course, the applicant first needs to receive the CA certificate in order to trust the CA. We saw that step. Then the applicant generates a private public key pair, and the private key is never leaked. That's the whole secrecy of this process of the private public key pair algorithms. And then the applicant generates a CSR, which is nothing else but its identity information and its public key. It puts those two things in a document, and it signs that document with its private key. Now, in the PKI enrollment process, the CA receives the CSR from the applicant, and as we saw before, it's going to first validate the signature in there using the applicant's public key, which is contained in the CSR. It's going to also validate the identity of the information from the CSR, and if those are correct information, then the CA approves and issues the certificate to the applicant. And of course, as we saw in the X509v3 format, it adds additional information like the validity dates, like how long is that certificate or passport valid, a serial number, identification number of that document, and the algorithm used to sign the certificate. And of course, the CA signs the certificate with its own private key. Now, when a certificate is being received, which again, let's go back to that process where Roy and Rick exchanged their public keys, which now what this means that when we exchange now the public keys is we're going to exchange now our certificates, which again, the certificates are going to be nothing else but our public key with our identity information signed by a trusted third party, which is going to be the CA. So let's see how the process is now different. So now when somebody receives a certificate, which means the other side's public key identity, the receiver checks first if it's issued by a trusted CA. Like when you go to the airport and they verify your passport, the first thing they do is, before they scan it, of course, they look at who issued that passport, what government, do we trust that government? Then the receiver verifies the CA signature. That's the process in the airport where they scan your passport through a specific scanner, and that's used to make sure that actually the certificate or the passport was issued by the proper CA, which they trust. So that's what happens when they scan your passport in there. So the second step is that they verify the CA signature, and then they check if the certificate is valid. So they look to see if the passport is not expired, because if it's expired, clearly it's not valid. And then also they check if the certificate has been revoked by the CA, which means they check in a database to see if your passport was revoked, because you may be a wanted fugitive, and the government, you're basically under arrest, to call it that way, and you're a wanted fugitive, and your passport is revoked, is no longer valid. Because it's one thing the passport to be no longer valid because it's expired, and another thing for the passport to be no longer valid because the government that issued you the passport has revoked it because you're a criminal. So when somebody now receives a public key from somebody else, which means the other side's certificate, they're going to perform all of those steps now. And that's going to, with those steps, is going to confirm that the public key of the other side is, first of all, valid. And second of all, is going to confirm that the public key belongs to the owner because it has been issued by a trusted entity which has verified that identity from the certificate. Depending on the use case, of course, other verifications are also performed. Now, as we said, because the government can revoke your passports, likewise, a CA can revoke certificates because they got leaked or whatever happened. They're no longer valid. It's a lot of use cases. So when a certificate it has to be revoked before before it actually expires per its validity date. If the CA has to revoke a certificate, what happens is that when somebody receives, when you send me your certificate, I have two options to check if that certificate is revoked. Like in the airport, they have a couple of options to verify if your passport has been revoked. And one of them is called the Certificate of Revocation List, CRL method, and Online Certificate Status Protocol, which stands for OCSP in there. Now the difference is, and again, the name of those two, the acronyms tell you exactly how they work. The CRL means that the CA periodically publishes a signed list of revoked certificates by the serial numbers to a certain location, and the PKI members download the CRL, that list periodically. So that's why it's called the Certificate of Revocation List. So it's like when a government, revokes some passports because of whatever reason, they're going to, for example, publish a list of revoked passport with wanted fugitives periodically in a specific location. Now, this is not good enough because this is being periodically being done. So like the C publishes that list of revoked certificates periodically, not like instantly. And of course, the verifiers download that list periodically, and it's not instantly. So OCSP is better because it's real time. What the CA does, it keeps the serial number of revoked certificates in an online database, and the PKI members query the database in real time. So nowadays, when you go to the airport and they scan your passport to see if it also has been revoked or not, they go online and in real time they verify in a database to see if your passport has been revoked or not. That's also OCSP. But again, also the naming convention of the acronyms tell you exactly how they work. So CRL stands for a revocation list, while OCSP stands for an online certificate status protocol. Now, per their, let's say, per their functionality, digital certificates have offer a couple of security functions. One of them is going to be the origin authentication, which is because when the applicant sends to the CA a CSR, because the CA validates the identity of the applicant before issuing the certificates, it means that certificates are going to prove origin authentication. So now when we exchange the public keys back and forward now, but in the format of a certificate, a public key certificate, Now, there is no way that when I send you my certificate, there is no way that you can say, how can I make sure that it's you who say you are in that certificate? Because when I send my request to the CA has validated my identity in that request. And since the CA has granted me the certificate, it means that when I send you my certificate to you, which is my public key information and identity information to you, as long as you trust the CA who issued my certificate, it means that that proves the origin of authentication. It proves that I am who I say I am, right? So one real use case of this is going to be that we use certificates in peer authentication in IPsec or SSL tunnels, for example. Another security function of using certificates is going to be confidentiality, because as we saw before, the public key, which is the certificate's key, is going to be used to encrypt data, and only the paired private key can decrypt it. One real use cases we're going to see is going to be in SSL tunnel negotiation. We're going to see exactly how in the SSL tunnel negotiation the public key or the certificate of the SSL VPN gateway is being used to encrypt data back and forward. Another use case is going to be integrity, and this is what creates a lot of confusion, because a private public key algorithm, a private public key scheme, depending on what security do you want to provide. The private key and the public keys, both of them can be used to encrypt something. So if you want to provide confidentiality, like if I want to encrypt a message out to you, then I'm going to use your public key to encrypt the message, because only you can decrypt it, because only the associated private key can decrypt the message. But if we want to provide integrity, then that's going to make use of the private key, which is used to sign a message or a data. I'm going to explain a couple how the digital signature works. But so when we want to provide integrity, we're gonna make use of the private key to sign a message or data, which that's also what the CA does when it issues the certificate to us. It signs the certificate request with its private key. It is also what happens when the applicant sends the request to the CA. It's gonna sign the request with its private key. Because it's very simple, right? If we want to prove integrity, if I'm going to send a document out to you, a PDF document, and I want to make sure that nobody makes unauthorized changes to that document. If I sign that document with my private key, because only I own that private key, the private key is not exportable, it's not shared with anybody. It means that when we receive that document with that signature, because I'm going to also send you my certificate alongside with the document, you're going to use my certificate, which is my public key, to decrypt that signature. And if the process is successful, it means that the document was sent by me. And also it was not modified in transit, because only I own the private key, nobody else. So likewise, the certificates can also be used to provide non-repudiation, which again, for that scope, we're going to make use of the private key to sign a message or data. And because a signed message, which makes use of a private key, provides proof of origin, the private key is only known to the owner, which means the owner can know. There's no way that the owner of the private key can decline having signed the document. So it's like if I sign a document with my private key and I send it out on the internet to people, to devices, there is no way I can state further at a later point in time saying I have not sent that document. Because the private key, only I know it, only I have it, I never leaked that private key. So it means that there is no way that that document was signed with my private key by somebody else but myself. So that's not repudiation. And one real use case for integrity and non-repudiation is going to be the document transaction or transaction digital signing. Which how this works is, so the digital signature is seen in multiple places. like the applicants, when the applicant sends the CSR information to the CA, is going to sign that CSR. When the CA issues a certificate to the applicant, is going to sign that certificate. And also nowadays we can sign documents to prove, to make sure that nobody can do unauthorized changes to the document, to provide integrity, and also to confirm that the document or the message was received from the real, from the to the proper origin. So non-repudiation. So how this process works is that the signer computes a hash or fingerprint of the data. So if I want to send you a document and sign it, I'm going to create a hash or fingerprint of that document using a known algorithm, MD5, SHA-1, or SHA-2. Then I'm going to use my private key to encrypt that hash value. And that signature, this becomes the signature. So the process of using my private key to encrypt a hash of a document, that's the signature. And that signature is going to be attached to the data that I send out to you, to the document. And when you receive that document, because the document contains also my public key, which is my certificate, then you're going to make use of that public key to decrypt the hash, the signature. If the process is successful, then it means that the document was not modified in transit, and it also means that the document was actually sent by myself. So looking back on Wikipedia in here, this is the digital signature process. So this entity wants to send something like a document, and he's going to digitally sign it to prove the fact that he has issued that document. So this is going to be the document, and I sign the document with my private key. So then what I do is I send that document over the wire to the other side. What I'm actually going to send in there is I'm going to send the signed document, which was signed with my private key, and I'm also going to send my certificate, which contains my public key. Now when the other side receives that document, the first step it's going to do is that it's going to look at the certificate, and it's going to say, okay, who issued that certificate? So it's going to look at the issuer of the certificate. So it's going to look at the issuer name, CA identity. And then I'm going to say, do I trust that CA? It's like, again, when you go to the airport and they verify your passport, the first thing they do is they make sure that that document was issued by a trusted government, right? So that you don't make your own passport in your home. If this process succeeds, then the next process which happens is that I'm going to validate the certificate that I received. So the first process was, do I trust the CA, the authority which issued that certificate? The second process is, we need to validate that certificate. So what that means is that because the certificate was signed with the CA's private key, then what I do, because I have the CA's public key, because I trust that CA, I'm going to use the CA's public key, which is nothing else but the CA certificate, to decrypt the signature of the certificate I receive from the sender of that document. And if this process is successful, it means that the certificate is valid and proves the identity of the sender of that document. And finally, I have to make sure that the document was actually signed with that certificate. So because now the sender when it sends that signed document, which is, so this is the signed document, because when it sends a signed document to the other side, it's also going to send its certificate. Then the receiver, what it does is going to take the received certificate, which contains the sender's public key, and it's going to use that public key to decrypt the signature of the attached document. In the process of decryption, I'm going to end up with the MD5 with a hash of that document. And then I'm going to compute my own hash of the document. And if the resulting hash that I performed for that document which I received matches the decrypted hash which was attached to the document, it means that first of all, the document was not modified in transit. And second of all, it means that the document was actually signed by the owner of the private key that signed that document. So it proves also ownership, data origin, and also it also provides integrity. Document was not modified in transit, and also provides non-repudiation, which means I know that the sender has actually sent that document to me, and the sender cannot decline having done that.